Welcome to another video on digital electronics. In this video, we'll be seeing how to do an analysis of a clock sequential circuit. So I have one circuit here and I have to find out the state table and the state diagram for the same. So the very first thing that you have to do is you have to first write down the equations of the flip-flops TA, TB and the output Y. And also first write down what type of a circuit is this, whether it is a Moore machine or a Mealy machine. This particular circuit is a Moore machine because Y is not influenced by the direct input X, which is in Mealy machine. So Y is what? A into B. Had you had X coming into Y, if you remember Mealy machine, then this would have become a Mealy machine, but with this not the case here. So this is a Moore machine because there is no X in this equation. So I'll write down the equation of the output and the flip-flops TA and TB. So what is my TA? TA is X, and into this X I have my B coming in the AND gate. So this is X into B. What is my TB? Input at the B flip-flop. It is directly X, nothing else. So TB is directly X. So first write down all the three equations. So since these are two flip-flops, I have only two equations. Had we had TC, one more flip-flop, one more equation would have come. Okay. Now we write down the present state. Since I have two flip-flops, A and B, how many combinations of the present state are possible? 4. So it could be 0, 0, 0, 1, 1, 0 and 1, 1. Then we have to write down the next state with both the combinations of the input. X could be 0, X could be 1 and the corresponding Y. For X equal to 0, what is my new A and B? And for X equal to 1, what is my new A and B? How do we find this? To do this, what you have to do is you have to put this value of 0, 0, this value of 0, 0 into these equations. And depending on the truth table of TA and TB, I will get my output. So let's first write down the truth table. For T0 I have Qn, for T1 I have Qn bar. This is Qn plus 1, the next state. That's my truth table. Let's do the first equation using the first values of A and B, which is 0, 0. So X is 0 here, A, B both are 0, 0. So X is 0, B is 0. TA will give me 0, which means the input to TA flip-flop is 0. Since it is 0, my output is whatever is your previous state. The output remains in the previous state. And hence my output here will remain in the previous state, which is 0, 0. Because X is also 0 here, TB is also 0. So for 0, my output will remain in the previous state. So 0, 0 will remain as 0, 0. Let's do the second one. For 0, 0 and X equal to 1, what is my new A and B? So X is 1 now, B is 0, this is 0, X is 1 now. So for TA, my input is 0, so my A will remain in the previous state. So A was 0, A will remain in 0, but my B input is now 1. So for 1, what is your Qn plus 1? Qn bar. So if this is 0, my new B will be 1. I hope this is clear. And what is your Y? Y is A into B. So A into B, this is calculated using a present state, which is 0, 0. So of course this is going to be 0 and this is also going to be 0. Let's do one more. For AB 1, 1, X equal to 0 and X equal to 1, let us find these two values. So I'll erase the previous one. Okay, so my A is, we are solving this. My A is 1, my X is 0, X is 0, B is 1, which means this is 0, and X is 0. So for 0 and 0, TA and TB, my value will be same as the previous one. So 1 1 will remain as 1 1. Both this 1 1 will remain as 1 1. Okay, let's do the second one. For x equal to 1, x is 1, b is 1, and a is also 1. So for 1 1, my both the states will change to qn bar. So see here, 1 1 both change to 0 0. TA and TB both change to 0 0 since your input was 1 1, and for 1 1 it is qn bar. So this is your present state, qn bar. Your next state will be complement of it, right? And this is calculated using the present state. So 1 into 1 is nothing but 1. So once you have written the state table, now you have to draw the state diagram. How many states do we have? 4 states, 0 0 0 1 1 0 and 1 1. So I have to do this 4 states. Depending on the input x equal to 0, I will move to the next state, and this is my output. So if my input is 0, I remain in 0 0, and my output is also 0. Similarly, you have to draw the state diagram. Do try it on your own to see whether your state diagram matches or not. Similarly, let's see one more circuit. So in this circuit, first we have to identify what kind of a circuit it is. It is a milli circuit. Why do I say this? Because the equation of y is having x directly, right? So I can see my x is getting connected here and here, and it is influencing this y. So if you remember the block diagram, this is your output logic, this is your next level logic, which are made using gates, and this is your memory element, right? So this is how you're supposed to correlate with the basic block diagram. Write down the equations, write down the kind of a circuit it is. This is a milli circuit. Equations dA, dB and y. So the circuit, if you check very closely, what is dA? It is addition of two things. So it is addition of two things. What are those two things? First one is x. First one is x. I will recheck the diagram again. So my dA is addition of x into QA and QB. So if I check here, this is QA. QA becomes QA bar and goes here. So I have a QA bar here in dB. So this line is QA bar and this is QB. QA bar into QB is my dB, and here I have QB. This is QB addition of x into QA. So I am missing one line of QA here. So this QA also goes here, right? So this is your equation for dA, dB and y. So what is your y? If you check this, y is having QA, and the second input is x, which is from here, QA into x, and this x becomes x bar using this NOT gate. So I have x bar here and QB bar here. So x bar into QB bar. So this way you have to properly analyze the circuit and the equations. Once you have the equations, again since I have two flip-flops, I will have 4 states, present state 0 0 0 1 1 0 and 1 1. Accordingly, you putting these values in the equation, I will get the next states. Remember, this is a D flip-flop. Since this is a D flip-flop, the truth table of D flip-flop will be different. So for 0 input you will have 0 output, for 1 you will have 1. Since we had used previously T flip-flop, it was reverse, right? So for 0 you had Qn and for 1 you had Qn bar. So by putting these values of 0 0 in these equations, you will have to find the values of next state and the corresponding output. So we can try for 1. So my AB is 0 0. So let's try for DA. X is also 0. So 0. My initial state of QA is 0. B is also 0. So DA is 0. For 0 my output is 0, right? So for 0 my output is 0. Similarly for DB, QA bar is QA is 0, so QA bar becomes 1. QA is nothing but A and B itself. So QA bar becomes 1, QB is 0. So 1 into 0 is 0. For 0 I have output as 0. So DB is also 0 for x equal to 0. Similarly, you have to fill this entire table and get the corresponding output using this equation. What is QA and QB that you are using here? Nothing but the present state value of A and B, right? So QA is nothing but your A and QB is nothing but your B. We are just representing as state QA. This is nothing but A flip-flop and this is your B flip-flop. So similarly get the output for this Y using the equation and the present state values of A and B. So x will be 0 here and x will be 1 in this case. So this you will get by putting x equal to 1 and this you will get by putting x equal to 0. So after this, the final step is to write down the state diagram, draw the state diagram using the state table, which I had done previously also. So I hope it is clear how to do the analysis. First write down the circuit, the equations. From the equations and by the truth table of the given flip-flop, you have to write down the next state and the output, and from the state table you have to draw the state diagram. I will stop the video here. Thank you for watching.